As Sarah mentioned, I will be the instructor tonight for Intermediate Python. My name is Ben. And like she mentioned, we'll be doing a lot of different stuff. So the purpose of this course is to build upon the concepts that we taught in the Intro to Python course, as well as cover some more advanced but still pretty fundamental concepts in Python, as well as programming in general. So by the end of the class, you should have enough knowledge to write some basic programs, as well as understand documentation enough to learn more on your own, depending on what it is exactly that you're aiming to do. So with that, let me share my screen. So tonight we'll be working in Replit, which is an online code compiler for Python. Unfortunately, it has changed a little bit since we originally wrote the course, and actually since we did the introductory course last time. So you will have to sign up in order to log in. But once you sign up and log in, you'll find this page with the scripts where we're going to write the scripts tonight. To start with, we're going to start by pulling data from a website. So querying a website can be pretty complex, but thankfully, somebody has developed a Python module that makes it pretty simple to do a basic query of a website. So Google, Facebook, if you want to get information from there, you can use this module. The module that we'll be using is called the requests module. And the main function that we'll be using is the get function. So I'll just copy and paste some code here. And so the three things that are going on in this script right now is we're importing requests. This is how you import a module in Python in order to be able to use it. From the request module, we're using the get function on a URL. So in this case, it's just Google. We'll just be pulling from Google. And we'll be saving what we get from the response into this response variable. And once that's done, we'll print the response out here. And so if I run this, you'll notice that I get something that just says response 200. So this response is a standard HTTP response. HTTP stands for Hypertext Transfer Protocol. It's one of the ways that information is transferred over the internet. And 200 is a specific code associated with an HTTP request. And the 200 code means the request was successful. So we connected and we got what we were looking for. If for some reason the request number was different, we could find what different responses mean online. So for example, you may have seen a 404 code, which means that the resource isn't there, what you're looking for isn't there. So there's all that type of different stuff that you can get from the HTML page. So we've got this object after we requested something from Google, but we're not really interested in the response object. Maybe we want to take a look at the text instead, the text of the site itself. So if I type response print response.text, what you'll see here in the right-hand side is a whole bunch of stuff. And basically what this is unformatted HTML. So if you go up here, you'll see it's a HTML document. And this is what the Google web page actually is. This is the code that makes up the google.com web page. So it's not super useful by itself because it's a little hard to parse, for a human, basically. But this short example shows you how you can use the request module to pull data from a website or to interact with a website in some way. So for the exercise for this section, what we're going to do is we want to, instead of looking at something from Google, we want to get the data from this URL here. So this is the data that I've constructed for the class tonight. So we want to pull it down and pull it down from the website so that we can work with it. So in order to do that, we'll start off the same way. We'll import the requests, import the request module. We've got the URL string here. So that's the website we'll be making the request to. Then we'll do basically the same thing. Make a GET request to the URL, and then store the text in the data variable. So if I go to this website, you can see what it is. And it's basically a file with a whole bunch of data in it, as well as a header. And this is something we'll look into more later on in the class. Are there any questions at this time? If so, feel free to ask them in the Q&A box, and I will do my best to answer them. So any questions, feel free to ask them. If not, we can keep going. So we've interacted with a website now. And now that we've pulled some data from the internet, we may want to store it somewhere so that we can use it later. Right now it's in a variable, but as soon as we close the Python program, we won't be able to access it from outside that. So we can't open it up and look at it on our computer. Reading and writing files in order to deal with data like that is pretty fundamental in programming, no matter what language you're using. In Python, the open function is the primary function that's used for reading from and writing to files. Open takes two arguments, the name of the file that we want to read or write, and the mode which we're using, the mode in which we're using the file, which is, like I said, usually either read or write. And what that returns is a file object. So what we can do, if I go here and just clear things out, we can open a test file. So I can say f equals open test.txt, and then I want to write something to that. So now I've got that f object. I'm going to do f.write. Or we can take a look at what it is. So f. So if you look at that, you see you've got stuff related to this file, and it just prints out the object. So maybe when we want to write something to there, we'll write this is some test text. And then we'll close the file, because if you don't close your file, it can get corrupted or something similar. So now if we look at our Files tab here, we'll notice that we've got test.txt. And if we look in there, what we find is the thing that we wrote in the terminal. This is some test text. So that's how writing to files works if you do it that way. However, this is not usually the safest or cleanest way of reading or writing files. If you use something that Python calls a context manager, we don't have to close the file once we're done with it. So I will copy and paste a snippet of code. So the context manager is this line here. It's also called a with clause. So we'll do the same open function. So it opens this file that we just wrote in a read with a read method. And then we're just going to read the contents of the file into this file contents variable, and then we can print the contents. So if I run this now, that shouldn't be happening. Let's take a, let's try this. Okay, there we go. All right, so what happened there is it opened up the file like we said it would, and then it printed out the contents, which is what we had put in there originally. Again, if you want to learn more about reading and writing files from your file system, you can go to the Python 3 documentation and read all about it. There's a bunch of useful documentation if you just Google search it. So again, if there's any questions on that, feel free to put them in the Q&A and I will answer them. So now that we've learned about creating files and writing data to it, we're going to talk about the operating system and the operating system functions and module that Python has. So how do we know where our data is saved? Python provides the ability to interact with our operating system from simple things like listing the current working directory and the files in it to creating directories, moving files around, and running system commands as well. So we can take a look at the OS module, which is the operating system module. And you can do things like get your current working directory. So if you do get cwd, that tells us the path that our code is running in. And if I do os.listdir, that will list everything that's in the directory we're running in right now. So if we look at this list, it has .upm, which is a private file of some sort. Then it's got our main.py file, which is this one here. And it's got our test file .txt, which is that file there. So it lists everything that's in the current directory. The OS module also has a lot of other useful functions. So you can check whether a certain path exists, for example. So we can say os.path.exists, see if there's a data directory that's false. So there's not a directory for data where we are right now. You can combine path parts together in an easy way, so you don't have to remember how your slashes are formatted. That's actually quite useful for porting code across systems, because I believe Windows tends to use backslashes, and Macs and Linux operating systems tend to use forward slashes. So you won't run into issues porting your code if you use something like os.path.join to hook things up together. So let's see, we can do period, data, and then test file.txt. And so that'll print out the path that we're interested in. And finally, if you wanted to, you could make a new directory with the make dir command. And that would make a new directory, new folder for you to use. I won't run that here, but that's an example of what you can do. Again, the OS module is pretty well documented. So if you have any questions, feel free to search online for the documentation, and it should be able to answer your questions. There's a whole bunch of stuff that the OS module does that we won't be able to get into tonight. So for the exercise to take a look at using the OS module, we're going to try to use it to create a data directory if one doesn't yet exist. We're going to write the script to download the wine data that we looked at before and save it in the data directory. So I'm going to get rid of that. I'm going to uncomment all this. Maybe not this. So that's what we had so far, is downloading it. We're going to want the OS module so that we can use it. We're going to set some path variables first. So our base directory is going to be where we are right now. So os.get current working directory. And our data directory is going to be the current directory joined to a new data directory. So we'll start with our base directory, and then we'll add data. We'll just call it data. Add a comment here. So this is the URL for the data. We made the HTTP requests. We're storing the data. And so we're going to check if the data directory exists or not. So we'll use a conditional. So if not os.path.exists data dir. We'll comment this, make new data directory if it doesn't exist. So we'll print something so we know what we're doing, making new data directory. And os.make dir data directory. So that'll make the data directory. Then what we want to do is set a file to save the data in. So make a data file variable. That'll be os.path.join. We'll join our data directory to what did I call it? I think winereviews.txt. And then we'll use the context manager to open and save the file. So we'll open the data file in a write mode because we want to write the data as, call this my file. You can call it anything, generally something with the name file or the letter F is pretty standard. And we'll say wine data is my file dot write. So now if I run this, I'll add a print statement. if I run this, small syntax error, so I'll do this data. That's what it is. So we stored the data in this variable there. We need to write it to the file. So we need to pass that as an argument to the write function. And I think we can get rid of that as well. So now if I run this, you'll notice the second time we ran it, it didn't go through this conditional clause because the data directory was already there. So if I look inside the data directory, we can open up this wine reviews, and it's what we saw when we looked at it in the browser. It's just that wine data that we got. Does that make sense to everybody? If not, as I mentioned, please feel free to ask a question. In the introductory course, we covered the basics of lists and dictionaries, which were those special Python built-in data types, but we're going to take a bit of a closer look at them now. We'll also learn about the new set data structure. Lists can be populated with data when they're created, but it's also possible to add data to lists after they've been created. So we can show a few examples of this in the terminal. So if I make a test list here with, just put the letters of the alphabet. If I print that off, just a list. So I can add something to it with the append method. So I'll add the letter D. You'll notice it didn't return anything, but when I print this now, it's got that on there. I can remove an item from a list. So I can remove A, for example. And again, it doesn't return anything, but if you look at it now, the A is gone. And finally, you can also insert an object into a list. This takes two arguments. It takes the index of where you want to insert it, and it takes the object you want to insert. So again, doesn't return anything, but if I look at it, now the A is back. And so if I wanted to do that again, maybe I'd put in the put in another index. Make sure I'm calling this correctly. And now if you look at the test list, we've added another A in there and an arbitrary index. So those are some of the methods that you can use to interact with list objects. Now, a small note. In the beginner class, we said that anything with parentheses associated with it, so something like this insert method here, we refer to that as a function. Whereas now we're referring to it as a method. So what's the difference between a function and a method? In general, functions take some kind of input and return an output. So in the case of this request.get function, the get function takes in a URL, someplace on the internet that you want to navigate to, and it outputs a response object that has the HTML text that you might want to use. So you put something in, you get something back. A method, however, acts on an object. And usually this happens by either getting something from the object or setting something on the object. So in the example above, these three things, append, remove, and insert were all methods because they were acting on this list object. They were changing the list object. It wasn't that we put something in and then we got something back. It's that we did a getting or a setting on this object. So in the case of insert, we were setting the A someplace in this list object. So that's the difference between functions and methods. And that's the reason you might hear somebody refer to one versus the other, a function or a method. So going back to lists, in addition to the functionality we've already covered, there's a few more useful things with regards to how you use lists. So another useful method is the index method. If you give the index method a list and a value, the index method will give you the first time that object is seen in the list. So if I go here to the command line and I do test list.index and I want to find the first index of B, that tells me it's at the index 1. So it's 0, 1, it's in the second location in that list. Another function that's quite useful is the split function. So when you call split on a string, it splits the string into a list using the separator that's been given. So for example, if we have a comma separated string, we can use split to split it up. So here I'll do test string. It's just going to be A, comma B, comma C. Then we can call test string dot split, and we'll split on a comma. And that'll return a list of the letters. So as you can tell, it might be useful for data later on. Finally, if we were writing a for loop, the enumerate function allows us to access each item in a list as well as its index in case we need that for something. So as you might recall from the introductory class, for loops typically work something like this. So for item in test list, we can print the item. And that'll just go through and print out everything that's in there. But now if we try this again, so for, and it's, yeah, for index an item in tests in enumerate test list, we can print, and you might remember the F strings from the introductory class as well. So we'll print item number, and then we'll say index, and we'll put the item in there. And so you see there, we got this nice list telling us what is in each spot in the list, because now we can access the list indices via the enumerate function. And in case you're printing something for human consumption and you don't want to use zero-based indexing, which is what Python uses for lists and such, you can actually specify a start parameter in enumerate that'll make things nicer. So now if I do the same thing, item number index, and that's going to be the item. Now, instead of going 0, 1, 2, 3, 4, we can start 1, 2, 3, 4, 5, which is a little bit easier for a person to read. So now we're going to take a look at combining what we've learned about lists with what we know about files. So one of the useful functions for this is the readline functions. The readlines functions returns a list where each item in the list is a single line in the file that we're opening. So we can use it in combination with a for loop to look at the beginning of a file, for example. So now that we've got the this wine data file, what we can do is get rid of that, get rid of this, so we don't need it anymore. Is we'll open up the wine reviews file and take a look at it. And we're going to limit this to just the, say, the first 15 lines. So now, if I run this, I can get rid of that. All right. So now if you look at that, we can see all the first couple lines in the data file that we downloaded. And again, we're using that the formatted string literals here, the F strings, to make our print statement look nice and to make things pretty clean. And next, we're going to talk about sets. So as I mentioned before, a set is a data type that's distinct from dictionaries or lists. And what a set is it's you can think of it as a list, but it's something that only stores unique items. So if, for example, you have let me go to the terminal here. You have a test list that has the same item repeated multiple times. You can use a set to find the unique items in that list. And you can convert between the two. So we'll do list set test list. So we're giving set a list that returns a set, and then we're passing the set into the list function to return a list again. So now we've gone from a list with duplicates to a unique set to a list with those unique items. The last thing that we'll talk about with lists is something called a list comprehension. So we'll take a look at this snippet here. Oh, there's a missing E. That's why I was wondering why that was there. So we're going to open the wine data file, read it in the line. So this will give us a list. Then we're going to take the first item in the list, which is the header, and we'll split that string on the pipe value to get the header columns. And then we're going to use this list comprehension here to print out the column titles. So let's run this. All right. So you can see this is the list of the headers on our data file, and we've given it a nice title case. So this is the list comprehension that we used. Now, what a list comprehension is it's basically a way of writing a for loop on a single line and storing the results in a list. So that's where this comes from here. So the object we're operating on is that list of the header columns. And then we're calling each item in that list call, that's the variable. And then we'll take the call string and make it title cased and store that in a list. So that's how we get that, get our final header columns list. So in addition to list comprehensions, we can use dictionary comprehensions that work the same way. So here, for example, instead of just constructing a list, we've got the curly brackets. So this is a dictionary, and we're doing a key, which is column.title, and the value, which is column.lowercase. But it basically works the same. So if I run this now, you'll see we just get a dictionary instead of a list. If there are any questions on that, feel free to put them in the Q&A. So for the exercise to use this, we're going to try to use for loops, lists, and dictionaries to summarize the types of wine by country in the wine data that we downloaded. So let's take a look at how to do this. So first off, we're going to print the headers. So I'm going to back up a little bit. So we'll import the OS module so that we can use that. We'll set the base directory and the data directory and set the data file as well. Read it in, print the headers. And then next, we'll print some example lines. So we can use a for loop again. And then we want to group the wine data by country. So we're going to start with an empty dictionary. Start with an empty dictionary. And then for each line in the wine data, outside of the header, because we don't want the header, we're going to say the values in that line are the line.split on the pipe value. And again, the country is the first. The country is the first column, so that's why we're using the 1 here. We're only picking out the first value. So country is going to be vals 1. And then we're going to check to see if the country is in the dictionary already. So if it isn't, we can add it. And then we'll add the second to last column to the list of wine types for that country. So we'll append vals -2. And again, that's -2 because the second to last one is variety. If it's already in there, then we can just append it as is without creating the country key in the dictionary. So then we want to see what the unique wines are. So we'll do a dictionary comprehension. So we'll say list set wines for country, comma, wines in our country dictionary that we've constructed dot items. So country.items separates things into keys and values. So the key is the country and the value is the list of wines. And so we're just going to shorten the country dictionary by making things unique. So we just want the unique wine varieties for each country. And then we can print out a summary of that. Country, comma, wines in the country dictionary dot items. And then we can print f/n country. And then we'll print the wines. Do a tab just to make things look nice. Do dot join wines. So what this little bit here does is it takes the list of wines that we have and it combines them with a comma. So that should be it. Let's see if it runs. And there we go. Now if you look at this, you can go scroll back through here and you get a nice summary of the wine varieties of any given country. So Spain, for example, they have all these types of wines. Morocco's only got a couple, but you can see all the different types of wines from that file that we have. So pretty cool, pretty interesting, and not too difficult to do. All right, moving right along. As I've mentioned, if you have questions or if anything is unclear, anything that I've typed is unclear, feel free to put something in the Q&A and I can explain it. In the exercises we've worked on so far, all the code that we've written, whenever we've come across an error, so like the syntax error that I got earlier, our program has crashed. It stopped completely, and we got that red text with the error message. That can be pretty frustrating if you're trying to get something to work, especially because an error doesn't necessarily mean that you don't want to run the rest of your program. It might just be something you want to make a note of. Thankfully, Python has functionality that allows for errors to be caught and handled accordingly. So this is usually what you see in a what's called a try-catch statement, or also a try-except statement. So I'll just copy this into down here. So this is our try-except statement. So we can run this script again. And you'll notice that even though we've got this red squiggly line here that says we've got an undefined name of test variable, the script still got down here and finished. So if you look out here, we've got the finished script there at the bottom, even though test variable is not defined. So that's a pretty simple example of a try-catch statement. But understanding how they work is essential for a lot of coding tasks, especially in cases when you may be not sure about the data that you're working with. So for example, when you're querying a website or reading a new file, a try-except statement will allow you to handle problems in the flow of the program without completely stopping your script. It's good coding practice to be as specific as possible with your exceptions, rather than just have it be something broad. So when you're thinking about what type of error you might expect, maybe you expect a key error or a syntax error. If you're scraping something on the web, maybe you want to look for some sort of request not able to be completed error, something like that. But if you have more questions about error handling, you can read more about it on the Python website. So for the exercise for this section, we're just going to modify the script that we've written so far to use a try except block for reading in the data. And the reason you might want to have this is because maybe this file doesn't exist yet. So we can do try here. And then we'll tab this over. Oops. And then accept file not found error. If we get that, then we can say print file was not found. We'll print the error. Set that as the E variable. Sometimes this is actually called error, so we'll call that. And then we want to quit the program, because if there's no data, there's no point in us trying to run summary on it. So we can just call the quit function, and that'll close out the Python program. So again, not terribly complicated, but a good example of something you might want to use a try except statement for. All right. So in the last part of this course, we're going to get into something that's a little bit cool. And so we'll be doing some data analysis with the Pandas library. So this code that we've written so far to loop through our data and analyze it and summarize it, it works, it's good, but it's pretty tedious to have to do that all the time, especially if you have a lot of data that you want to be analyzing. So thankfully, somebody has already written a package for data analysis that's a lot easier to use, and you don't have to write all your own loops and functions and all of that. So Pandas is a very popular Python package for data analysis, and you can do all sorts of stuff with it. We'll take a brief look at it now. So the one thing that you have to do if you're using Replit to do this is you'll have to add the Python package. So I'll just search for it here, and I can add this, and you'll be able to use it. If you're working on your computer or working on a server, you will have to use pip install to add Pandas in order to be able to use it. But we'll just wait for a second to let the installation finish. So it's installing some stuff, installing Pandas. Just gotta wait a little bit. And if you have questions about the Pandas documentation, we'll go through it a little bit, but their documentation is pretty robust. So if you have anything that you want to do, let's see, it's getting started. Let's see, API reference. So like if you want to read in something from Excel, for example, it's got the read Excel function to read in an Excel file if you're reading from HTML, which is kind of what we've been doing. A lot of these are more specialized, like Feather or Parquet, are specialized storage formats. But SQL, if you want to query a SQL database, you can use that. CSV, very popular. Data is often stored in CSV format. So the Pandas documentation is pretty expansive. But okay, we'll go ahead while we wait for that to install. But okay, so we had this here, so we'll keep everything there the same. But now instead of using the with the context manager and read lines to open our file, we'll say wine data is pd.read CSV data file, and the separator is the pipe value, and there's a header in the first row. So that will do everything that we want it to do. And then instead of having to split up the lines based on the delimiter, we can just say print wine data dot columns. And so now we've replaced all that code with essentially 2 lines. It's just a lot cleaner, a lot easier to read. So now if we want to get the unique wines by region, we're going to go ahead and delete all this code that we wrote here, because we're going to refactor it to use Pandas, print unique wines by country. And then I'm just going to copy this because I can never remember what the proper syntax is. But so we'll walk through this. So we've got the wine data, which is the CSV that we read in. We're going to group by country. We're going to pull out the variety column, and then we're going to check the unique values for that by country. So now let's run this and see what pops out. And there you go. So it's not quite formatted the same as our original program was, but it achieves the same result. So if we go back to Morocco, for example, you can see that they've just got those 2 values. Argentina has however many. And you can see the unique wine varietals by country. And now we've got 17 lines of code, and a lot of that is white space and imports to do what took us, 50 or 60 lines of code before. So now for the last, for the exercise for this section, we're going to write a function that lets you summarize the data by an arbitrary column and by arbitrary groups. So I'll say function to summarize data. So we'll do we'll define our function, summarize data. We'll take in a data set. We'll take in a column to group by, and the column that's getting grouped. So then we're going to say, this is the doc string. So actually, I'll take this out of the comment and put it in the doc string for this function. We'll say result is data set dot group by, we'll say group by column, and then we'll say the grouped column, and then dot unique. And then that will be what we return the result. And then we can test it out, so we can print the summarized data. We'll say wine data, we maybe want to group by what are they? Let's see, points. We'll score by the points that a wine got. And we want to look at the unique countries. And then we can try this again just to show that it's pretty versatile. The data set is still wine data. We want to group by, let's see, price. And I'm going to see variety. So we'll just see what that spits out here. All right. So looking at the group of points, you can see here, the countries with the highest points is only US and Spain in our data set. And the most expensive bottle of wine in there is a red blend. So again, just another way of looking at the data, another way of writing a function that's a bit more general than writing a specific group by. So now we're going to try to make this interactive for our user. We want the user to be able to query the data as many times as they want. To do this, we're going to make use of a while loop. A while loop in Python is very similar to the for loops that we've studied before, except that a for loop iterates a specified number of time or over objects in a finite set of objects. So a list, for example, has a finite number of items in it. A while loop evaluates a logical condition in order to know when to stop. It'll be something like, while value A is not equal to value B, then you'll do something, and you'll exist in that loop. So that's useful for getting user feedback. So what we're going to do is we're going to write a function called getUserInput. In order to do that. And so I'll just copy and paste that in here, and then we can walk through it. So it's going to take in a data set and get the user input. So first, it's going to print the column headers. And then while true, it's going to ask them using the input function, the column that you want to group by, and the column that you want to be grouped. And then if there's some sort of value error, you'll get an error message. And if you enter a value that's not in the valid columns, you'll have to try it again. So we'll make a. Now I'm just going to clean this up a little bit more. So we'll have a data loading function. So we don't need this anymore. We don't need the header columns. We have the summarize data function. So we've got a function to load data that just uses the read CSV and a try catch statement and returns the wine data. We have the summarize data function that we've written before. And we have the user input that we just ran through, which uses the while loop to get the user's input for which data they want to analyze. And then we'll write our gameplay function. So if you look at the gameplay function, we'll just load the wine data, get the user input, summarize, and then keep playing. And then we'll add this statement here to make sure that it runs when our script runs. So let's give this a go. Okay, so it prints out, welcome to our data analysis game. We'll be analyzing some wine data. The wine data has has these columns. So maybe we want to look at something by, let's look at, we're going to group by country, and we want to look at price by country. And so then that prints that off, and you can take a look, see what wine costs in every country. So we want to keep playing. Maybe this time we want to group by points and look at price. So now you can see that maybe price isn't correlated with points, or maybe it is. Maybe we can try one more thing. So we can say we want to group by, we'll group by country, and we'll see the wineries in each country. And so here you can see the name of all the wineries in the data set by country. And maybe now we're tired of playing, so we'll exit the game. And then we're back at the terminal. But so what you can see with this is that with 4 pretty simple functions and about 84 lines of code, we can have a little bit of a kind of fun data analysis game going that uses a lot of different Python things that we've learned tonight. So we've learned about reading files in, writing files, working with the file system, importing modules, lists, for loops, while loops, all sorts of good stuff that helps you build these robust Python programs. And so that is the end of the course. So congratulations. If you made it this far, you've built out an interactive data analysis app from the data that you downloaded from the internet. And I hope that this gets you excited to continue your journey with Python. As we mentioned in the introductory class, there's a whole bunch of things that you can do with this. So this is just one example of data analysis. You can build web applications. You can build deep learning scripts or machine learning scripts. You can hook it up to sensors. You can use it to read PDFs or Word documents or PowerPoints. You can use it for basically anything under the sun. It's a very versatile language. And so with that, I'll close the course, but I'm happy to answer any questions that people have or things that they'd like to know more about. So feel free to ask a question, and I will do my best to answer it.